Hello and welcome to the third session of Physics 10. This is Sir CJ, and in this session we have the following parts. The first one will be activity number 2, test mag 1 2, and then testing for it's actually about testing for evidences of magnetism. The second activity naman is activity number 3, induced magnetism, which is actually an activity where we are going to induce magnetism and infer polarities. So, alin yung north, alin yung south end ng mga magnets. And then, the last part naman is activity number 4. It is titled Detecting and Creating Magnetism. We will be doing the first part, which is part A, titled North Meets South. So, this session, this third session of Physics 10, is revolving around the following learning competency, which is for you to be capable of citing examples of practical applications of the different regions of electromagnetic waves, such as the use of radio waves in telecommunications. Let's begin. For the first part, Activity 2, Test Mag 1 2, we will be testing for evidences of magnetism. To understand electromagnetic induction and its applications, especially on electric motors and generators, the next set of activities will help you revisit concepts about magnets and forces associated with it, checking polarities, and analyzing various magnetic fields. You already have some prior knowledge, some prior understanding of what magnets are and how they function. You also know what kind of force is being exerted by magnets on other magnets and other kinds of materials, whether magnetic or non-magnetic. What we will be doing in this activity is you will be recalling everything that you know so far about the topic about magnets. All right, so the objectives of this activity are as follows. The first one is for you to identify the forces, whether it's attraction or repulsion, between, say, two magnets and a magnet and a magnetic or a non magnetic material. The second objective of this activity is for you to distinguish a magnet, whether permanent or temporary, from a non magnetic object. The materials you will need for this activity are the following. You have to have at least around I think siguro two pieces or at least one piece of a working 3 inches to 4 inches bar magnets. You need 6 to 10 objects, random objects that are made of different materials inside the room. And then of course you need your science notebook and your pen, or maybe some sheets of paper depending on the instruction of your teacher. In my case, I think you will be using a 1/2 crosswise sheet of paper for this activity. Safety precautions before you proceed with this activity. You need to remember that you should handle magnets with care so as not to drop them. Do not drop them, okay? They might break, they might chip off, or they might also weaken. Their magnetic force might weaken upon impact. Also, you have to keep magnets away from computer units or computer screens. You have to keep them away from memory storage devices and disks, magnetic tapes, mechanical watches, and the like. So please make sure that whenever you're working with something in the laboratory and when we are discussing these safety precautions, you follow them closely so that you won't damage any property or you won't hurt anybody. All right. So for the procedure, the first part of this procedure, the first step is the following: use a bar magnet and explore the possible effect or effects it can have on the other magnet when it made to interact. So on your science notebook or on your sheet of paper, you have to draw this table, a table that looks like table number 4, titled Interaction between two permanent bar magnets, and record the observed force, effect, or effects. Now, after recording the effect or effects of the magnet on those objects, what you have to do is you have to answer the guide questions. Alright, so I will now give you time to do this step. Once you're done, you may just continue the video. After a short pause, I assume that you have played the video because you're already done. All right, let's now proceed to the next step in this activity. Step number two, this time, you only use one bar magnet and explore its possible effects on around 6 to 10 different objects found inside the classroom. So, what you have to do is record the observed effect or effects on a table like table 5. That is, you exclude record on objects with no observed interaction with the magnet. So if they neither got attracted or repelled by the magnet, you have to exclude them from this table. Okay, so again, let me clarify that the first table is about magnet. Okay, about magnets and how they interact with each other. So if you have around two magnets, you will just be having only one. You'll be only using one row. But maybe if you have different kinds of magnets, you can just you know uh, do it differently. Kasi ang nililimit lang dito actually is two permanent bar magnets. But if you have different kinds of magnets, then go ahead and go bananas in your activity. In this one naman, you will be using only one bar magnet, and then the other materials you will be using are non magnet materials. So they must not be magnets. Although they can be magnetic, okay, they can be non-magnetic. Um, what you do is you have to make sure that you exclude those that are non-magnetic. And then, yung mga magnetic naman, yung may interaction, you classify their interaction. Was it an attraction or was it a repulsion? Okay, so if you're done with this table, we'll proceed with the next part of this activity. Okay, turns out the next part of this activity is answering guide questions. Remember, the first table is between magnets, the second table naman is between a magnet and another material. Preferably, that material is reacting to the magnet. So it can either be attracted or repelled by the magnet. Okay, so timbawa, if the material you used did not do anything when put next to a magnet, then do not include that in the table. We're clarifying that because you might need to use your tables in answering the following guide questions. The first guide question is question number 7. What conditions with observable effects make magnets interact with another magnet? Okay, if you're done answering this question, let us proceed to the next one. Question number 8. In general, what conditions with observable effects make magnets interact with magnetic materials? Again, in general, what conditions with observable effects make magnets interact with non-magnetic materials? Okay, the next one is question number 9. What type or types of force can a magnet exert on another magnet? So remember your previous lessons, your former lessons to answer this question. Let us now proceed to the next one. I think the next one is also a question. What type or types of force can a magnet exert on non-magnet objects? Let's check again. So question number 9 is about a magnet interacting with another magnet, whereas the next one naman, a magnet interacting with a non-magnet object. Are you through? Okay, this one is question number 11. How will you distinguish magnets from non-magnetized magnetic materials? Alright, so kumbaga, what are the characteristics of magnets that make them different from non-magnetized magnetic materials? Alright, that ends the series of guide questions. What we'll now be doing is we will check your work. So I guess you have there prepared a red or a green pen so we can check your work. Okay, these are the answers to tables number 4 and number 5. For table number 4, the interaction between two permanent bar magnets, you will be observing these kinds of relationships. Okay, so if your observations are written here, maybe in a different using different words, you can consider the your answer to be correct, a correct observation. However, if your answer is nowhere near any of these in terms of concepts and in terms of words, in terms of meaning, then take the initiative and of course mark your work for the meantime incorrect or inaccurate. First one is the students or you may possibly opt to place the first magnet on a flat horizontal surface and bring one end of the second magnet near the other magnet's end. So, yung dulo ng isa, ilalapit mo sa dulo ng isa. So, ano yung mga pwedeng ma-observe na effects natin dito? The first magnet may move closer, okay, to or farther, pwede rin yun, from the other magnet. And when the unlike poles are close enough, they will stick together, closing the gap. So, kapag halimbawa nilapit mo yung north sa south, yung north ng magnet 1 tsaka yung south ng magnet 2, they will surely be moving closer to each other, closer until they snap together and they will just close the gap. Walang space in between them. But in the event na you put the north end of magnet 1 next to the north end of magnet 2, what might happen is they will just move farther from each other. Okay. Now, there's a second scenario where the students, you, may also place the first magnet on a flat horizontal surface and horizontally bring one end of the second magnet near the first magnet's middle part, or move the second magnet in circles over the first. So in this case, you are not laying them kumbaga head to head. You are kind of like laying them side by side, or maybe parang in the form of a T. Okay, so the first magnet may rotate towards for attractive forces, or maybe away from the repulsive forces the second magnet. Pwedeng halimbawa, naka lay horizontally flat on the table yung isang bar magnet. And then yung end naman ay nung isang magnet is north and you are moving it closer to the middle of the other magnet. What's gonna happen are actually one of these two things. Yung north will be pushing the other north end of the horizontally placed magnet. That can happen. So mangyayari nun, ipupush niya palayo yung north end, which will make it rotate and move the south end of the its south end, okay, closer to the magnet. Okay, so pwede siyang mag-rotate in a way na lalayo yung north tapos lalapit naman yung south dun sa hawak mo na isang magnet. Now, in the second table naman, we only have one expected scenario, pero may dalawang pwedeng absurd effects dito. So these are the contents of table number 5, interaction of a bar magnet with other objects. So, sample objects may be, say for instance, mga metallic na notebook strings. If you're using mga notebooks na merong mga parang springs, tas metallic sila. Ayun, yun. Mga paper clips, mga pens with metallic casings, mga 25 centavo coins, if you still are keeping 25 centavo coins, mga key holder chains, mga keys themselves, metallic hairpins, and etc. Now, what is expected from the set of materials that you will be using in this activity ay dapat meron silang mga interactions with the magnet. So halimbawa, ang ginamit mo is a ball pen cap. Tapos yung ball pen cap is made of plastic entirely. And then when you were moving it closer to the magnet, wala talaga siyang interaction. Ang gagawin mo nun, hindi mo i-include yung observation na yon dito sa table. Okay, so wag mo nang i-include yung mga objects na wala namang naging interaction with the magnet. So lahat ng to expected, may mga, as we expect, they will all be having some kind of interaction with the magnet. See this, metallic hairpins. May mga hairpins siguro na gawa entirely of plastic. Nevertheless, hindi sila na-mention dito. Specifically, we are mentioning metallic hairpins because that is what the activity is asking us to do. Now, the expected observed effect or effects are the following. Yung mga objects that are small enough will move towards or attach itself or themselves to the test bar magnet. Now, yung mga some parts naman of big objects will be attracted to any part of the test bar magnet. So this one, mga effects na to, depends on the size of the object that we are dealing with. Limbawa, if you are dealing with, say, a very big notebook spring, one na parang binder na siya, ganun, part of it is just gonna be attracted to the magnet. Kumbaga, not the entire thing. Or maybe it depends on the power of the magnet, pero since we're working in a school laboratory, we expect the magnets to be of the usual kind of attraction, to have or to possess the usual amount of magnetic force, which does not usually which is not usually very strong. Okay, so again, ang sinasabi lang dito ay kung yung mga objects na ginamit ninyo ay maliliit, yung buong object ma-attract siya dun sa magnet. Kung masyado namang malaki yung object, just a part of that whole big thing is gonna be attracted to the magnet. Okay. Now, the answers to the guide questions for activity number 2, test mag 1-2, are the following. Answer to question number 7. So, what conditions with observable effects make magnets interact with one another? So, the answer to this question is as follows. The magnets that are good in condition are strong enough to push or pull another magnet close enough to it. So, some magnets may not be in good condition. So, they will be weak. Okay? They will be so weak to push or to pull another magnet that is close to it. However, if the other magnet is, say for instance, really strong, even though the other magnet is really weak, there will still be some kind of attraction, pero it's not gonna be as strong as you would expect from two magnets that are super powerful. For answer number 8 naman, in general, what conditions with observable effects make magnets interact with non-magnet materials? Now, this is interesting. Ang mga magnets, whether strong or weak, they can be made to attract non-magnet materials that is made of or has parts that are magnetic in nature. Pag sinabi nating non-magnet object, ito yung mga object na hindi sila magnet. Okay? So, they can be made of different kinds of materials. But in this case, we're talking about non-magnet objects that have, say, iron, say nickel, o kaya cobalt, or any of its alloys. What we're trying to say here is if the condition is between a non-magnet material, but it is a material, an object that has any of these metals, that possesses any of these metals, and a magnet. Kumbaga, if it's between a non-magnet object with any metal and a magnet, the general rule is, or the general occurrence, the usual occurrence is, they will be attracted to each other, or at least the object is still gonna be attracted to the magnet, despite the magnet's weakness or strength. Ayan, so that is the answer to question number 8. Question number 9, what type or types of force can a magnet exert on another magnet? Okay, so magnets can exert either a pull, so that's attraction, or a repel or a repulsion, that's the push, against other magnets. Okay, again, yung dalawang uri ng forces, it can be push or pull. So pag halimbawa, attraction ang nangyari, that is a pull. And kapag naman halimbawa ay repel, that is a push. Okay. Now, like poles of magnets, kapag north and north, when they are close enough, will cause the magnets to repel each other. While unlike poles of magnets, say for instance north and south, when they are put close enough to each other, they will cause the magnets to attract each other. Yan. So, in other words, yung rule pa rin natin, even sa charges, yung mga like charges, they repel. Yung mga unlike charges naman, they attract. Same with magnetism. In question number 10, what type or types of force can a magnet exert naman on non-magnet objects? Okay, so remember in question number 9, it was between two magnets. But this time, it is between a magnet and a non-magnet object that possesses, a metal. Now, both poles of the magnet can attract. Okay, pwede silang makapag-attract ng mga non-magnet objects that have materials or parts that are magnetic or metallic in nature. That's more appropriate siguro. Now, let us emphasize that the only force that will take place is force of attraction. So puro lang siya pull, kumbaga, walang pushing, no? You cannot expect a magnet to push away a piece of nail. You cannot expect a magnet to push away a piece of a paper clip, a metallic paper clip. It's always pulling. Okay, it's always pulling. The next one is question number 11. How will you distinguish magnets from non-magnetized magnetic materials? Again, magnets and a non-magnetized magnetic material. Only magnets can repel other magnets and already magnetized objects. Tanging yung mga magnet lang ang pwedeng makapag-repel, pwedeng makapag-push, okay, away ng mga magnets or ng ibang mga object na nabigyan na ng magnetic forces. Ang mga non-magnetized objects naman made of magnetic materials can only be attracted. Pwede lang silang ma-attract by a magnet. And let me remind you, hindi sila yung mag-a-attract, no? Ma-attract sila. Okay? Pero hindi sila yung mang-a-attract ng mga magnets. There's a difference. Because only magnets and already magnetized objects have magnetic forces in them. Ang mga non-magnetized na mga objects naman, they are simply possessing the ability to be attracted to a magnet or to an already magnetized object. Okay. So, kumbaga pag pinagbalibaligtad natin to, tanging ang mga magnets kaya nila mag-push or pull, ang mga non-magnetized magnetic materials kaya lang ma-attract. Okay? Hindi nila kayang mang-attract, kaya lang nilang ma-attract. Alright. Now, the key concepts for this activity, Test Mag 1, 2, testing for evidence of magnetism, are as follows. The first one is that magnets exert either a force of repulsion or a force of attraction. And then, if a force of attraction is being concerned, it is only possible between an object and a magnet. Then, the object interacting with the magnet contains ferromagnetic substance, could be iron, and is considered naturally magnetic. Now, if a force of repulsion is also possible between an object and a magnet, then the object interacting with the magnet may also be a permanent magnet or a temporarily magnetized ferromagnetic material. So in the in the second bullet, what it's talking about is between a magnet and non-magnetized magnetic material. Okay? The second one naman is between a magnet and another magnet, or a magnet and another magnetized magnetic material. Okay? All right. So that is it so far for the guide questions. Now, in the module, there are there's this one extension question which we can consider answering. So it is asking, what are the magnetic materials found in the audio and video recording tapes? Okay. Think about it. If you have seen already mga cassette tapes ganun o kaya mga Betamax ba yung tawag doon? Okay. Si mga films, no? If you have seen one or maybe if you haven't, you can search for how they work and answer this question by yourself. What are the magnetic materials found in the audio and the video recording tapes? All right. So that ends the first part of this session. This is activity 2, test mag 1 2, testing for evidence of magnetism. The second part of this session is another activity. It is titled activity 3, induced magnetism. In here, we're going to be inducing magnetism and inferring several uh, concepts about polarities. The objectives of this activity is for you to be able to induce magnetism in a magnetic material, and then for you as well to be capable of inferring the polarity of a magnetized object. Now, the materials you will be needing in doing this activity are as follows. First one, you need a bar magnet. No, I hope you still have a powerful bar magnet in your school. Second one is a for 1-inch iron nail. You can have several of them, screws or maybe paper clips. Just make sure that if you decided to use nails, you use all nails. If screws lahat, screws lahat. Kung namang paper clips, please paper clips lahat. Wag naman mixture, okay? And then the last one is of course your science notebook and your pen. And in my case, I think I might be asking you to use a 1/2 crosswise sheet of paper. All right. I think we also have to mention this safety precaution before we proceed with this activity. You make sure that you handle the magnet with care so as not to drop it. If you break it, if you chip it off, it can actually weaken as well uh, upon contact or upon impact. So, pag halimbawa nahulog mo siya, pwede siyang mabasag, pwede siyang mag-chip. Okay? And in the process, pwede siyang manghina. Mawalan siya ng magnetic force. So, syempre, kapag ganun, baka hindi mo rin makuha yung observation na ina-expect namin from you. Okay? So, make sure that you handle your magnets carefully. Alright. Now, for the procedure, the first step is for you to use the bar magnet and nails to find the answers to the questions that will follow. Now, what you will be doing is you have to record your answers on your science notebook, and you also have to use the diagrams to support your answer. Now, what are you going to do? Using the bar magnet, ang gagawin mo lang is ihilera mo lang yung mga screws o kaya yung nails tsaka yung paper clips. And then, you make sure by saying, by saying hilera, I mean you lay them down tapos you make a line where one end, the sharp end of the first nail touches the head of the second nail, and the sharp end of the second nail touches the head of the third nail. Ganon. Okay, and then dun sa head ng first nail, that's where you put the magnet, or that's where you put the magnet in contact. Now you record your observations and then answer the following guide questions. Question number 12. What happens if you bring two iron nails close or touching each other? Now this time, just get your two iron nails and just put them side by side. What are they doing? What's happening? Okay, question number 12. That is already done. I hope that you did it. Alright. Now for the next question, question number 13. If you bring a bar magnet close to or touching the first iron nail, can the first iron nail attract and lift a second nail? Do it. Now, if it does that, can it still attract a third one? Alright. Answer this question. Alright, if you're done, let us proceed. Question number 14. What happens if you vary or if you change the distance between the magnet and the nails? What's gonna happen? That is question number 14. Question number 15, we have this consideration. If the north pole, as in this case, of the bar magnet suspends the first nail, as in this case, by attraction, what is the nail's polarity? So itong sa area na to ng nail, ano ang polarity niya? What is it? Is it north or south? Okay. Now, kung north or south ang kanyang polarity dito, ano naman ang polarity nung last nail over here? Sa may sharp end niya. What is its polarity? Is it north or south? What do you think is the reason why? Okay, if you're through, let us now proceed to step number 2. Now, what you have to do in step number 2 is simply choose the correct term from the enclosed choices that should go into the blank spaces on the Sum It Up challenge. Are you ready? Okay, this is the Sum It Up challenge. The process in which screws become magnets is called, number 1, electric, magnetic, induction. This same process is the reason why magnets, number 2, attract, repel, non-magnetized magnetic substances such as the screw. The screw becomes, number 3, a permanent, an induced magnet with the end nearer the magnet, having, number 4, the same, an opposite polarity to that of the permanent magnet. Hence, attraction happens, number 5, after or before magnetic induction occurs. Choose your answers from within these parentheses and write them as number 1, 2, 3, 4, and 5 on your answer sheet. If you're done, let us now proceed. These are the answers to the guide questions. For guide question number 12, what happens if you bring two iron nails close to or touching each other? There will be no observable effect or event in bringing two iron nails close to or touching each other. Syempre, like, they're just laying there side by side. Nothing's really gonna happen. The answer to guide question number 13 is as follows, but first the question is, if you bring a bar magnet close to or touching the first iron nail, can the first iron nail attract and lift a second nail? How about the third one? The answer is, a bar magnet brought close to or touching the first iron nail makes the first iron nail capable to attract and or lift a second nail and another or so depending on the magnet's strength. If the magnet is super duper strong, you can expect it actually to lift a lot of a lot of nails. However, if the magnet is extremely weak, then maybe you can just lift two nails in that instance. That is the answer to question number 13. For question number 14, what happens if you vary the distance or change the distance between the magnet and the nails or nail? Well, the first nail may still be attracted to may still be attracting the second nail and another one, the third nail or more, depending on the strength of the induced magnetism. But it will be not as strong as before when the magnet was still close to or touching the first magnetized nail. What it's trying to say is that the first nail is the most attracted nail of them all, okay? The attraction that is being done on the second nail is weaker, and then the third nail, it will be weaker, the fourth if ever, it will be weaker compared to the first nail that was attracted in direct contact with the magnet. Alright, that's question number 14. This one is question number 15. If the north pole of the bar magnet suspends the first nail by attraction, as in this case, what is then the nail's polarity of induced magnetism in the indicated regions and why? So the head of the nail over here will be south, and then the tail of the nail or the sharp edge of the nail, the third nail over here, will be the north side. So it's like north becomes this is south, and then this one becomes north, attracting the south of this nail. This one becomes the wait lang, ulit. This is south, this is north, and then this is south, attracted south, and then this is north, and then this is south, and then this is north. Yes. So if you put another screw or another nail over here, the head of that will become south. Very good. Tapos the tail, the sharp edge will be north again. Now, the head of the first screw served as the magnetic south-seeking pole by principle that, unlike magnetic poles, attract and like magnetic poles repel. Thus, it can be said that the free end of the screw served as the magnetic north pole. So, and as you add more nails into this line, new north poles or north ends are gonna be added into the mix. Okay. Now, these are the answers to the Sum It Up challenge. Okay, so reading the entire passage now, or the entire paragraph now, the process in which screws become magnets is called magnetic induction. This same process is the same reason why magnets attract non-magnetized magnetic substances such as the screw. The screw becomes an induced magnet with the end nearer the magnet having an opposite polarity to that of the permanent magnet. As in the case kanina, yung north ng magnet, it resulted to turning the contact point with the first nail to be south. Ganun siya. Okay, so hence, the attraction happens after magnetic induction occurs. So, nothing will be happening before magnetic induction. Kaya yung mga nails nung pinaglagay lang natin sa side by side, nothing really happened because magnetic induction hasn't happened yet, hasn't started yet. Now, a quicker way to know the polarity of a permanent or induced magnet is by the use of a magnetic compass, which you will be using in the next set of activities, which is also the last part of this session so far. Now, for activity number 4, detecting and creating magnetism, this is part A, north meets south. You will be having the following materials, and these are the sets of objectives we have. The first one is for you to be capable of identifying the polarities and strengths of a bar magnet and magnetized objects using a compass. And then the next objective is for you to demonstrate magnetization by stroking. The materials you will need are medyo marami. The first one is at least 2 small magnetic compasses, mga button compasses, preferably. Mga maliit lang talaga sila. The second one naman is a 1 3-inch iron nail. Alright, and then the third one is a masking tape or maybe a cork stopper. The next one is a piece of paper, any small scooping device, pwede yun. Make sure that the paper you're gonna use is good for scooping. You can make a scoop out of it. Be sure that the paper is not also super crumpled, no, it's not weak, ganun. Kumbaga medyo may stability siya, ganun. A cellular phone and any gadget with a camera, a strong bar magnet, so let's take note of the term strong, a narrow test tube that is 5/8 inches wide, or a clear straw that has around a diameter, I think, of a 5/8 inches. And then your science notebook and pen, and then iron filings. For the science notebook, you may also be using, I think in my case, in my classes, you may use a 1/2 crosswise sheet of paper. Now, these are the materials you will be needing in this activity, and these are the precautions that you need to remember before you proceed. So, you have to first make sure that you use the magnet, compass, the test tube, and the gadget with the camera with care so as not to drop any of these inside your laboratories. Make sure as well that the iron filings remain sealed inside the test tube or the transparent straw. Now also, avoid the iron filings from sticking directly to the magnet. Do not let those iron filings, stick directly dun sa magnet mismo. Alright, now the procedure. For checking polarity, step number 1, you place one magnetic compass on a horizontal surface, then move a bar magnet around and above it, exploring the strength and polarities of the magnet. Now, the compass is supposed to just be laying flat on the table or on a horizontal surface. Do not move it, okay? The only thing that you'll be moving around it and above it will be the bar magnet. Now, if a cellular phone or a cell phone or any gadget with built-in camera is available, please take pictures of the magnetic compass needle orientations for different locations around the bar magnet. Now, draw the compass needle directions and write your observations regarding the magnetic field strength of your science notebook or on your answer sheets, and answer the guide questions that will follow. So again, so far that's what you did muna, no? Remember that this is just part A, north meets south. Kaya ganyan siya kabilis. Alright? Alright. Now, question number 16. What happens when you randomly move the bar magnet roundabout and above the compass 1 foot or farther? Now, if you haven't done this yet, kung hindi mo siya in-estimate na around 1 foot or mas malayo, then do it. And also, in the same question, you need to answer the following. What if it's nearer than a foot? So if it's less than 1 foot, what are the observations? Answer this question. Now, if you're done, let us proceed to the next question. Question number 17. Now, compass needles are tiny magnets that are free to indicate the north and south poles of a magnet. Now, what do you need to do to know the magnet's polarities? Again, what do you need to do to know about the magnet's polarities? Alright, that is question number 17. This one naman is question number 18. Now, what does the compass needles indicate about the iron nail shown below in figure 6? So this is just a simple iron nail, okay? And then this iron nail is just laying flat on the table next to these two compasses. Okay, so what do you think are the compass needles indicating in this case? Alright, that is it for the guide questions. Let us now answer them. So please get a checking pen. Either red or green is accepted. Let us answer the following questions. Answer the guide question number 16. What happens when you randomly move the bar magnet roundabout and above the compass 1 foot or farther? How about nearer than a foot? Now, there are several answers to this question. It can actually also take, so much time in answering this question. But all of these are accepted. Okay. Alright, the first one. On exploration of the compass's ability to indicate the magnet's strength for button compasses, when the bar magnet was moved around the compass 1 foot or farther away from the still compass on a horizontal surface, the compass needle slightly deflected clockwise or counterclockwise, or nothing happened to it at all. For moving the bar magnet in circles a foot or farther above the compass needle slightly rotated in the same direction, or nothing at all. Now, observe that when nothing is happening, maybe it is because of the weakness of the bar magnet that you're using. The second acceptable answer is as follows. On exploration of the compass's ability to indicate the magnet's strength for button compasses, but when the bar magnet was moved around the compass nearer than a foot from the compass needle deflected clockwise or counterclockwise more noticeably. Kumbaga, nung mas lumapit siya, mas nag-react yung mga compass needles. Now, for moving the bar magnet in circles nearer than a foot above the compass needle rotated more easily in the same direction as the rotating magnet. Mas nakakapag-follow yung compass needle doon sa magnet the closer the magnet is to the compass. Another another acceptable answer is on exploration of the compass's ability to indicate the magnet's strength, this time for bigger compasses that have magnetic needles twice as long as that of the button compasses. The above observations a while ago are much more noticeable even at a 2 feet separation from the same magnet. because this time we're dealing with needles that are longer, that are bigger compared to the other needles kanina na mas maliit lang. Mas noticeable, mas napapansin yung paggalaw ng mga needles when you move the bar magnet above it as well as around it. Now, this suggests that the longer needle has greater attractive or repulsive interaction with the magnet compared dun sa kanina na mas maliliit yung mga needles. Now, another acceptable answer on exploration of the compass's ability to indicate the magnet's polarity for all noticeable deflections, yung parang pagre-repel, when the north end of the bar magnet is brought near the south end of the compass needle, you will observe that the needle is attracted and moves towards the magnet. Okay? Now, when the magnet is moved around the compass in whatever direction, the compass needle will always be following it. So, halimbawa, ang tinunok mo naman ngayon is yung south end ng magnet. Ang tuturo nun is not the south end of the compass needle, but it will be the north end. Alright, now the north end will be following the magnet wherever around the compass you put it. And then another acceptable answer for question number 16 on exploration of the compass's ability to indicate the magnet's polarity is when the north end of the bar magnet is brought near the north of the compass needle, the needle rotates away from the magnet's north end due to repulsion until the south end of the compass needle is nearest the north end of the magnet. Now remember, kapag tinutok mo naman is the south end, sa south end ng needle, mangyayari, yung south end ng needle iikot. O kaya parang lalayo siya. Ang lalapit nun is going to be the north end of the compass needle. Now we move on to question number 17. The answer to it is going to be discussed right after the reading of the question. So, the compass needles are tiny magnets that are free to indicate the north and south poles of a magnet. Now, what do you need to do to know the magnet's polarities? Now, what you have to do is you have to lay the magnet on a horizontal surface and place the button compass right next to the magnet's north end. Now, the compass needle will point away from the magnet's north end. Again, the compass needle will point away. So that means the needle that we're talking about here is actually the north end of the compass needle. Now, when you move the compass towards the south end of the magnet along the horizontal surface and see the compass needle pointing towards the south pole of the bar magnet, you will know which it is. There are times when siguro yung bar magnet does not have any indication kung alin ba yung north, alin ba yung south niya. Although, usually may letters talaga yan and usually may mga colors din sila. I think N is always blue and S is always red. Pero yeah, nevertheless, just to be sure, what you can do is you put a compass next to it, and if the compass's north needle is pointing towards a particular end of the magnet, then that end of the magnet will be south. Okay, so ganun siya. Now, if the compass needle naman is pointing it's a really long magnet and then it points to slightly towards one end to the right of the magnet or to the left of it, then you can expect that end to be always the south of the magnet. Okay, so north of the needle of the compass always pointing south of any magnet. Now for the next question, this is question number 18. The compass needles for checking an object's magnetism through the presence of two opposite poles, as you can see over here. Because both compass needles are still aligned along the same north-south geographic direction, we can infer that the non-polarized, non-magnetized iron nail, though it's magnetic in nature, does not have any magnetic force yet. Again, these compasses kasi, they are really bound to pointing to the directions of the poles on the earth. Okay, so if you put halimbawa this nail and nothing happened, walang nagbago dun sa direction nila, we can infer that this material is not yet magnetized. Hindi pa nag-start yung magnetic induction sa case na to. Alright, that is activity number 4. I can't believe that we're done already. Ang dami activities nito. Congratulations to you. The first part of this session was activity number 2, Test Mag 1-2, testing for evidence of magnetism. And then the second part naman is activity number 3, Induced Magnetism, which is about inducing magnetism and inferring polarities. And then the last one naman is activity number 4, detecting and creating magnetism. We finished the first part, which is part A, North meets South. So all of these parts are revolving around the following learning competency in Physics 10, which is citing examples of practical applications of the different regions of the electromagnetic waves, such as the use of radio waves in telecommunications. This is Sir CJ, and I hope that I will see you in the next session of Physics number 10. Have a good day.